I have given you 4 homework sums. Have you all solved? I think so many of you sent me, but there's still some of you not answered. So just verify either your answers are correct or not. So what is the first compound I have given homework with actually ammonium?
Magnesium nitrate.
No, that is the first magnesium nitrate is the first one I have given homework.
No, sir. Ammonium carbonate, sir.
Ammonium carbonate. So ammonium carbonate, ammonium is NH4 and carbonate is CO3. So that is what. So what is the valency? Ammonium is 1, carbonate is 2. So if you have done the crisscross, Mr. Johan, what will come? Ammonium carbonate. You should tell me fastly. NH4 twice. Read it as a
Bracket
twice. All of you remember it is read it as a how? Twice. NH4 twice. CO3 1. So 1 is not necessary to represent. So that we will say, what is the formula of ammonium carbonate, everybody? NH4 twice CO3. How to read it one? Everybody should read NH4 twice. Twice it is called as. Next. Second one is called as calcium hydroxide. So calcium hydroxide, you all people knows what is the ions present here? Anyone can tell what is the cation? Harini? Calcium is the cation, hydroxide is the anion. Now calcium valency, everybody's calcium valency is what? 2 and hydroxide valency is 1. So if you have been done the crisscross, you should learn also. Of course you have done, but you have to learn. So now what will come, guys? Everyone should tell me. Ca1 and OH twice. Please, all of you remember twice. We should read it as a twice. Okay, so the formula will become CaOH twice. That is what? Calcium hydroxide. Mr. Kaushik, you never answered me. Next, copper sulfate. If you have taken the copper sulfate, what is the formula? Everybody can tell me. Copper sulfate, Harini. Yesterday itself I told you. Copper sulfate. What is the copper? Copper is Cu. Sulfate is SO4. So copper formula is 2. Sulfate valency is also 2. So if you have been done crisscross, what will come, guys? Everyone, what will come? We are going to get, open your mouth, Cu2 SO4 twice. Now, if both subscripts are same number, as I told you, you have to bring it into the lowest fraction. So 2 will get cancelled. So we are going to get copper sulfate means what is the formula? All of you. CuSO4. That is what it is you have to remember. Yesterday's class also I have taught you one thing. You might be remember. Calcium sulfate. Yes, Mitaksri, calcium sulfate I have taught you or not? Same way. Aswin, understand Aswin now? That is what you have to remember. If the same thing is coming, you can just bring it into lowest fraction. Next. Last one is ammonium sulfate. So these are the 4 homework questions. Sorry, aluminum sulfate. So I hope everybody done well. So totally 13 or 14 compounds I have given you for ionic compounds for writing the name. So aluminum, Al, sulfate is SO4. What is the valencies of aluminum? By this time you can tell me. What is the valency of aluminum? Harish? Kaushik?
3, sir.
3. Sulfate valency is 2. So if you have been done the crossing, we are going to get, what is the crossing we are going to get, everybody? Al2 SO4 thrice. Remember, you should read it as a thrice. Al2 SO4 thrice. So it is not possible to bring it lower. So itself is the formula. The chemical formula is of aluminum sulfate Al2SO4 thrice. So till here it is ionic compounds. So some of the important ionic compounds and their chemical formulas, everything I had taught you from the yesterday. Now all these tabular column, what is the page number tabular column? Any one of you?
37.
37. One will be having one tabular column. The tabular column must be in our mind. Then only you can write the chemical formula. So now this all the chemicals what we studied from yesterday and today, everything is what compounds they are? Ionic compounds or covalent compounds? Everyone, they are the
Ionic.
compounds. Okay. Now today's class we'll see the covalent compounds also. But before going to study the covalent compounds chemical formula, let us study the properties of ionic compounds. Very, very important. Even in class 10th, it will be reappears again. Properties of ionic compounds. Please keep reading. Shall we start? Everyone. Good morning, Mr. Nimish. Good morning, Harish Jaras, Arun Kailash. Everybody, good morning. Now, first one.
Good morning, sir.
Observe very carefully. Ionic compounds, if you notice it, is it formed by sharing of electrons or donating and receiving of electrons? That is my first point. Everybody should tell me. What is the first point? It is formed by how? By sharing of electrons or by donating and receiving? Anyone? Ionic compounds.
Donating and receiving, sir.
By donating and as well as what, guys? Donating and receiving electrons, no sharing. So by donating, it will form one ion. Anyone can tell me what is that ion called as? By donating, positive ion. Positive ion. What is the name of the positive ion? Mr. Harish? Sorry, Mr. Johan? Johan, what ion it is called as? By loss of electrons, it is called as cation. And by by receiving electrons or by accepting electrons, we used to say it will form negative ion. What is the name of the negative ion, Harini? Only one day response. Today gone.
Anion.
Anion. That is what you have to remember. So ionic compounds will formed by two ions. What is that ions called as? What is ions called as? Cations and anions. That is what you have to remember. Harini, are you writing the notes?
Yes, sir.
Right. Ionic compounds are made up of. Ionic compounds are made up of. Ionic compounds are made up of positively charged ions, positively charged ions, or else you can write simple word, oppositely charged ions, then it will be both will finish. Oppositely charged ions, oppositely charged ions, which are called as cations and what is it called as? Everybody, cations and anions. So that is what the first property. So always remember, cations means positive charge by loss of electrons or by donating electrons, and receiving or accepting, it is called as anion. Is it okay, Gokul? Next. So because of, as it is forming by donating and receiving electrons, the force of attraction is very, very high. So that is why ionic compounds are very strong. We will say they have high melting and boiling points. Is it okay, everyone? They're having high melting and boiling points because ionic bond is strong bond or weak bond? Ionic bond is very, very strong bond. So melting and boiling points is high. Next one, third point. You might be remember, basically this salts, whatever we are getting, these ionic compounds, everything they will be in solid state. Ionic compounds, they exist in what state, guys? Majority of the substances is existed in We are having three states of matter. First state is solid state. So if you notice these ionic compounds, majority of the ionic compounds exist in solid state. So that is the one of the property. Now, if you notice it here, these compounds, when they are in solid state, this is a major important one. Remember, ionic compounds are in solid state. Solid state, they are very poor conductors of electricity. Understand, Harizeras? Poor conductors of electricity. When what state? When they are in which state? Everybody. When they are in solid state. Understand, Abhirami? Now, the same ionic compound, when I dissolved in water, so that it will form one state. I taught you so many times. Anything is dissolved in water. What is that state called as? All of you.
Aqueous state.
Aqueous state. Understanding? So when they are dissolved in water, aqueous state, they are the best conductors of electricity. Is it okay, Hari? Gokul?
Yes.
Remember, Mitakshri and everybody, when it is dissolved in water, we used to call it aqueous state. Or directly, if a solid is converting into liquid, that state, as we know, what is that process called as? Melting. So this liquid is called as molten state. What we used to call, everyone? Molten state. Understanding? So then also it is a good conductor of electricity. Either when the ionic compounds are good conductors, everybody, when ionic compounds are good conductor, when two things, when they are dissolved in water, then also they will be behaves like a best conductors of electricity. Or when they molten state, means they melted into liquid state, then also they are best conductors of electricity. Is it okay, guys? Please respond. Yes or no? Clear? So this is what the four important properties of ionic compounds. The most important property is last one. When they will conduct the electricity, only when they are in which state? Everyone. When they are in which state? When they are in aqueous state, means the ionic compounds are dissolved in water or they melted into liquid. They are the good conductors of electricity. Is it okay, clear? Please respond. Yes or any? That is what you have to remember it. Write all the four properties. So when this is the point which will come in class 10th, around 2 chapters you will get the same thing. Properties of ionic compounds. Based upon that only will decide either the chemical reaction will take place or not. So that is what you have to remember it. Is it okay, guys? Clear? All of you? Any doubt or clear?
Yes.
That is now. So once you understand this, then we are going to write just very few examples of covalent compounds, and later we'll go to the most important one, atomic mass and molecular mass. Okay. So now please keep it in. Chemical formula of some covalent compounds. Chemical formulae of some covalent compound. So remember, covalent compounds also is to called as molecular compounds. What is to call? Molecular compounds, another name of this one. So what is the bond present here? Covalent compounds means what is the bond present here? Bond present here is called as what? Everybody. The bond is called as covalent bond. So it is a weak bond. It is a weak bond. Okay, not having strong force of attraction. This covalent bonds is forming only by sharing of electrons. No donation, no receiving. Only by what, guys? Only by sharing of electrons is only called as covalent compounds. So these covalent compounds only shown by non-metals and non-metals. So till here, anyone having any doubt, please let me ask. Arun Kailash, Nimish, clear? Harini, are you writing? Johan, I'll check it, Mr. Kaushik, you are also. So that is what you have to remember. So who will form the covalent compounds? Metal and non-metal, or only non-metal and non-metal? All of you.
Non-metal or non-metal?
Non-metal and non-metal.
Non-metal. That is what you have to remember. So first example, ammonia. Example 1, ammonia. So tell me what is the constituent atoms present here? Symbols. Ammonia means what is the formula? You all people know already. So the constituent atoms present here are nitrogen and hydrogen. The constituent atoms are nitrogen and hydrogen. Okay. Now symbols. What is the symbols of nitrogen? Tell me. What is the symbols of nitrogen? N, and hydrogen is H. Now, what is the valencies? You all should tell me. Valencies, please. Valency, please. What is the nitrogen valency? Anyone? You can see the tabular column. It is there in our book. But you should learn it. That is what I want. All of you should learn. What is that? Anyone? Nitrogen. Check it. Above it will be there. Somewhere elements they have given. So there you will find it. Nitrogen atomic number. Nitrogen atomic number is how much, guys? 7. Okay. So its valency is 3. You should learn, guys. As it is there, chapter 4. You have to learn it. Valency is 3. And hydrogen, what is the valency? Anybody can guess? Hydrogen. Always how much?
1.
Only. So here no donation or no receiving, only by sharing electrons. So that what is the crisscross formula will come? Ashwin Balaji, you should tell me. Now here what will come? N1H3. So 1 is not necessary to show. I will write what, guys? All of you. NH3. So this is the chemical formula of ammonium. NH3. So one nitrogen is sharing the electrons with how many hydrogens? Akilan, one nitrogen is sharing the electrons with how many hydrogens? One nitrogen is sharing electrons with how many hydrogens? All of you.
3, sir.
Hydrogens. That is what atom ratio. What is the atom ratio, Abhirami? What is the atoms ratio? Check it. 1:3. Means 1 nitrogen, 3 hydrogen. So now if we take mass ratio, can you tell me what is the mass ratio of anyone? Nitrogen. 1 into 14 is to 3 is to 1. So which is equals to 14 is to 3. So they will never be bring it into lowest fraction. So always what is the mass ratio of ammonia? Everyone? Mass ratio is how much? Yes.
14 is to
3. You have it or not? Check in your books. Is there it or not? 14:3. Yes or no? Harish Jairas? Kaushik? No response at all. So in page number 36, you will be finding that nitrogen and ammonia 4:3, 14:3. Have you noticed it or not? Yes. That is what you have to remember. Next, you take methane. Methane. So if you have taken the second example, so methane, if you will notice, so tell me what is the constituent elements are present? The constituent atoms are carbon and hydrogen. What is the formula of methane? Anybody can tell? I already taught you so many times. Mitakshri, Gokul, Akilan, Methane formula CH4. Okay. So now symbols is symbols. Notice it. Symbols is C and H. Valencies is 4 and 1. So if we'll done the crisscross, so what will come? All of you should tell me. C1 H4, which is equals to CH4. So this is how the chemical formula will be obtained for the covalent compounds. Anybody is having any doubt? Please kindly let me know. Are you clear, guys?
Yes, sir.
Yes. So that is what you have to remember. So what is the element ratio here in methane? What is the element ratio? Element ratio. Element ratio 1 is to
1
and mass ratio. Mass ratio, tell me fastly. Mass ratio 1 into 12 is to 4 is to 1, which is equals to 12 is to 4. So 12 is to 4 will be divisible by some table. What is that? By 4. Okay, yes or no? So what is the ratio, guys?
3 is to 1.
3 is to 1. So that is what mass ratio. Hope everybody clear with this. Any doubt? Write it now. Gokul, understand Gokul? Akilan?
Yes, sir.
Yes. Please write it. Nimish, completed Nimish? Arun Kailash? Completed? Yesterday only I told you, but never. Okay. So now we'll go to the next concept. This is what the most important concept in our entire life, like we can say, as you are in a chemistry field or you are in normally whatever it is, intermediate everywhere. So this is the one which is the most important concept in our life. That is what measurement of atomic mass and as well as molecular mass. So we all need to know this measurement of atomic mass and as well as molecular mass. Now, you might be having somebody is having doubt, sir, how we are getting these valencies? So basically that valencies we will study in the 4th chapter only. So by the time you will understand what is this valencies and all, I will explain you clearly. So no issues. Now, the concept which you are going to study is measurement of atomic mass and molecular mass. Please keep heading. Measurement of atomic mass and molecular mass. Okay. Now, shall we start, guys? Everybody, any doubt? Anyone, please ask. Shall we start? Okay. Now you tell me, suppose if I'll ask you 1 kg rice, you people can measure. If I'll ask you, suppose 10 kg rice or 1 kg dal or whatever it is, I will ask you, or 1 liter oil or 1 gram gold, everything. Why, guys? Is it visible to us or not visible to us? Anyone? It is visible to us. They are bigger in size, so that we will measure in the quantities like kilograms, liters, whatever it is. But if we take the atom, atoms are extremely smaller. They are the smallest particles of a matter. Is it possible to see in them easily? That is what my question. Anyone? Is it possible to see the atoms easily? Yes, please.
No.
No. So that is why, do you think that is it possible to measure the mass of an atom individually? Suppose I'll ask Mr. Harish to measure the mass of a atom. Suppose let me imagine this is the single atom. I will ask him to measure. Is it possible to measure individually? Gokul, Akilan? No. Why?
No, sir.
We cannot see them with our naked eye. So as we cannot be seen easily, we people cannot carry in our hand. If people cannot carry, it is not possible to measure. It is very difficult is to measure the mass of an atom individually. So that is why the measurement of atomic mass or molecular mass, as it is difficult to measure by normal weighing. So we are going a different thing that is called as relative atomic mass. What is to call, everybody? Relative atomic mass. So this is what the one which is help us to find the mass of an atom and as well as mass of a molecule. Is it okay, everybody? So because we are not measuring the atom mass in ordinary ways, because it is extremely small, we cannot even see it easily. So that is why it is difficult to measure the atom individually. So that is why we are going with the relative atomic mass, which we used to call as RAM. Please remember, RAM. RAM means what? Relative atomic mass. Now, if you want to measure the molecule, of course, molecule also very small. So that is why we will use one more thing. That is what we used to call as RMM. Anybody can tell me what is this called as? RMM. Relative molecular mass and relative atomic mass. So let us see what is this relative atomic mass. Of course, instead of atom, if I'll keep molecule, both are same only. That is what. So write it, everybody. Keep adding relative atomic mass. Relative atomic mass, right? When the mass of an element is, when the mass of an element is, when the mass of when the mass of the element is compared with some standard reference elements, some standard reference elements, then the atomic mass is called as, then the atomic mass is called, what we used to call Harizeras? We used to call as relative atomic mass. So
Yes, sir.
what do you mean by relative atomic mass means? For example, see, when you are calculating the grading system, you might be here nowadays grading system. Who is getting the first mark? Is not that based upon the top marks, based upon the number of students. They are going to compare the one standard result with the results of a person. That is the same principle here we are using. We are measuring the mass of a particular element with some standard reference elements and their masses, so that we people can easily will approximately can guess the mass of an atom of an every element, same way as well as molecule of an compound. So now let us take for example, first if you'll take, as we know, who is the first smallest known elements to the humans? Lightest and smallest known elements. All of you. Yes, all of you. Tell me. Anyone? Hydrogen. So in olden days, if you have taken hydrogen as reference, they are taking. Do you understand, everybody? Hydrogen is our reference atom. So the atom mass of any atom, they are comparing with the hydrogen atom. So that is how they used to measure the atomic mass of an other elements. So olden days, hydrogen has taken as the reference, just like in physics concept. Recently, we studied one concept called as, what is that concept? Anybody can tell?
Relative density.
Relative density. So based upon the relative density, how we can say object will sink or float or below the surface? RT is greater than 1, sink. RD is equals to 1, float below the surface. RD is less than 1, float above the surface. Do you remember that, everybody?
Yes, sir.
That is the same thing. So this relative atomic mass is similar to the relative density of the substance, which means it is compared with some other substance. Is it yes or no? Relative density we are comparing with the whose density? Anyone can tell? I taught you so many times. Relative density we are comparing with the whose? A density of a substance with water. Same way here, mass of any atom, that is what atomic mass. The atomic mass of any atom, we are comparing with the mass of which element? Everybody. Mass of an hydrogen. Understanding? But this is very, very old method. So olden days only hydrogen they used to compare. But present days today we are taking as carbon 12 as our reference. So that is what we are saying, and that is also I will say. So hydrogen as a reference, but not now. But not now. Because the reason hydrogen is not stable. Not stable. It is having if I want to exactly say, we will study in the next chapter. It is called as, it is having so many isotopes. So that is the reason it is not considered as a reference atom. Remember this word called as isotopes, which we will study in the next chapter. So initially, hydrogen was taken as the reference, and as it is, we all know that it is the lightest gas, and mass of hydrogen was taken as 1 unit. So just consider as a 1 unit, as it is a lightest gas. So the masses of other elements were compared with the hydrogen. So how, sir? Let us see. For example, you all know beam balance. You all know beam balance. How many of you know beam balance? Beam balance. Yes, please. Beam balance means to measure the weights. Yes or no? Like this one. You never seen? In your house also, if somebody of you are having. Yes, please, everyone. Harish. Now,
yes, sir.
One side we will keep the stone. 1 kg stone, half kg stone, like that stone. Do you remember that, everybody? Yes or no? Same way here, for example, I want to measure the oxygen atom. Oxygen atom mass. Then I will keep one oxygen atom here. Then whom I am comparing? With whom I am comparing at initial stage? Initially with whom? Everybody. Please respond. With whom it is? Yes? Hydrogen. So this side I will add hydrogen atoms. Then I will keep on checking 1 oxygen atom is equals to how many hydrogen atoms. So for example, if you take 1 oxygen atom, if you have taken, which is equals to 16 hydrogen atoms, means in the sense of, as we know, hydrogen atom, what is the mass has been taken? The mass of a hydrogen atom is 1 unit. 1 unit. So what is the 1 oxygen is equals to 16 hydrogen is coming. So that what is the oxygen atomic mass? Anybody can tell? What is the oxygen atomic mass? Everybody. 16U. Because 1 oxygen equals to how many hydrogens? 1 oxygen mass is equals to how many hydrogens? 16 hydrogens it is coming. So that is what we will say. 16U is the atomic mass of oxygen. Like that we used to find. Are you clear, Harish? Harish Eras? Please respond.
Yes, sir.
That is what. So they are comparing with the hydrogen. Now that is why they form the formula also. Relative atomic mass of an element. Please write. Relative atomic mass of an element. This is olden days, guys, at initially, now not. Element which is equals to mass of one atom of given element, mass of one atom of given element, same way like relative density divided by, with whom we are comparing, guys? Anyone? Mass of one atom of hydrogen. Is it okay, everybody? Please respond. Yes, please. All of you. So, but later hydrogen is not considered as is a convenient because of its isotopes. I will teach you what is isotopes later. So now you just remember at initial stage hydrogen is considered as the relative atomic mass, but later it has been proved not inconvenient. It is not inconvenient to take hydrogen as the reference. Hydrogen as reference. So that is why later days, some other scientist has been taken oxygen as a reference. Oxygen as reference. Do you understand, everyone? Please respond. Yes, Hari? So, after hydrogen, they have taken oxygen was taken as the reference for the measurement of atomic masses. But again, here also some problem with the oxygen. So that is why oxygen is also not considered as standard one. So later we have taken what? Anybody can guess what we have taken later? Divya? Carbon 12 as our reference. I will say what do you mean by carbon 12. Okay. Oxygen as our reference. So here also same thing. They will take the beam balance. All of you remember. For example, if you have taken one side oxygen atom. Okay. So now